Question 4. The scores for reliability tests administered on 10 students admitted into the BSc of Zoology and Environmental Biology program, University of Calabar, twice within 2 weeks is as follows. Here we have row 1 applicant numbering 1 to 10, row 2 scores in week 1, row 3 scores in week 2. A. Plot a scatter diagram of the data. What does it tell us about the relationship between the two sets of scores? B. What is the magnitude of the correlation coefficient? C. Test the significance of R, that's the correlation coefficient, at P equals to 0.05 level. Solution. A. This is a scatter diagram for the two sets of data. The scores in week 1 are represented in the horizontal axis, while scores in week 2 are on the vertical axis. So these are the scattered points. From this scatter diagram, it is revealed that there is a linear relationship between the two sets of data, and the straight line here represents the fitted trend line. Now, to compute the correlation coefficient between the two sets of data, here is the data. The first column here, X, represents the data in week 1, Y represents the data in week 2. So we have to create a column for XY, that's multiply X by Y to obtain this column. Create another column for X squared, that is square each observation here to obtain this column. Another column for Y squared, square each observation here to obtain Y squared. The sum of X is 536, sum of Y is 505, sum of XY is 32045, sum of X squared is 34826, while sum of Y squared is 31525. So, to compute our correlation coefficient, we make use of the product moment formula given by this: R equal to n sum of xy minus sum of x times sum of y, all over the square root of n sum of x squared minus sum of x all squared times the square root of n sum of y squared minus sum of y all squared. This will give us n is 10, that is sample size n is 10, times sum of xy, which is this value 32045, minus sum of x, which is 43, minus sum of x, which is 536, times sum of y, which is 505, all over the square root of n, which is 10, times sum of x squared is 34826, minus sum of x all squared, that is 536 squared, times square root of n, which is 10, times sum of y squared, that is 31525, minus sum of y all squared, 505 all squared. This is equal to 320450 minus 270680 all over the square root of 348260 minus 287296 times the square root of 315250 minus 255025. So, and this will give us 49770 all over the square root of 60964 times the square root of 60225. And this is equal to 49770 all over 60593.4. Dividing, we obtain 0.8214. So that is the correlation coefficient between the two sets of data. C. To test for significance of R, we are testing the null hypothesis rho equal to 0, meaning that there is no linear relationship between the two sets of data. We are testing this against the alternative hypothesis H1, rho is greater than 0. That is, there is a linear relationship between the two. The test statistic is given by t equal to r square root of n minus 2 all over the square root of 1 minus r squared. This is equal to, we recall our r was given to be 0.8214 times the square root of n minus 2. 10 minus 2 is 8 all over the square root of 1 minus 0.8214 all squared. Simplifying this will give us 4.07. The critical value of t at p equals to 0.05 significance level and 8 degrees of freedom. The degree of freedom is n minus 2, is t 0.05 with 8 degrees of freedom, and this is equal to 1.86. Conclusion. The test is significant since t calculated, which is equal to 4.07, is greater than the table value, which is 1.86. So we therefore conclude that there is a linear relationship between the scores in week 1 and week 2. Question 5. A biologist is interested in predicting weight loss of adults from distance covered per day during an exercise program. The following data was collected on 6 clients at a weight reduction intervention clinic. The first row here represents the client, numbering 1 to 6. Second row, distance covered, and the third row, weight loss. A. Determine the equation of the line. B. Test the hypothesis that there is a significant linear relationship between weight loss and distance covered at p equals to 0.05. C. What is the predicted weight loss for the client who covers 6 kilometers per day? Solution. Estimated regression equation of the weight lost on the distance covered is given by y estimate equal to a hat plus b hat times x, where x here represent the distance covered while y represent the weight lost. A cap and b cap are the regression parameters to be estimated, where b hat, that's the regression coefficient b hat, is given by the formula n sum of xy minus sum of x times sum of y all over n sum of x squared minus sum of x all squared. Here x, as before, represent the distance covered, while y represents the weight lost. Then create a column for xy, multiply x and y to get this column. Create a column for x squared, that is square each value here to obtain this. The sum of x is 29.5, sum of y is 47, sum of xy is 275.75, and sum of x squared is 165.75. Putting them into this formula, we have b hat equals to n is 6, that is 6 times 275.75 minus 29.5 times 47 all over 6 times 165.75 minus 29.5 squared. This will simplify to 2.16. Now to obtain a hat is given by y bar minus b hat x bar. Y bar is 47 divided by 6, and that will give us 7.83 minus b hat, which is 2.16 times x bar. X bar is 29.5 divided by 6, and that will give us 4.92. So simplifying this will give us minus 2.8. So therefore our estimated regression equation of y on x is given by y estimate equal to minus 2.8 plus 2.16x. B. The hypothesis of interest here is the null hypothesis b hat equal to 0, meaning that there is no linear relationship between the two set of data. We are testing this against the alternative hypothesis that b hat is not equal to 0, that is, there is a linear relationship between the two. The test statistic for this hypothesis is a t-test statistics t equals to b hat all over the standard error of b hat, where the standard error of b hat is given by the formula the square root of n sigma squared all over n sum of x squared minus sum of x all squared, and sigma squared is estimated using the formula 1 all over n minus 2 sum y minus y estimate all squared. This is how this is done. This column is for our x, this is the column for our y, this is the column for x squared. To get the column for y estimate, we recall that our regression equation of y on x was given by this y estimate equal to minus 2.8 plus 2.16x. So for each value of x, when you put the x here, that will give you the y estimate. So for x equals to 2.5, that will give us minus 2.8 plus 2.16 times 2.5. That is how we obtain 2.6 here. For x equal to 6.5, when you put 6.5 here, that will give you 11.24, and so on. So the sum of your y estimate here is 46.92. To obtain y minus y estimate all squared, you have to subtract y estimate from y. Here 2 minus 2.6 all squared, that will give you 0.36. 12 minus 11.24 all squared, that will give you 0.58, and so on. So that the sum of all this, the sum of y minus y estimate squared, is equal to 3. So therefore our estimate of variance is 3 divided by 4. Remember, n is 6. 6 minus 2 is 4. 3 over 4 will give us 0.75. So therefore our standard error of b hat is equal to the square root of n sigma squared over n sum x squared plus sum x all squared Putting in the values here, we have square root of n is 6 times sigma square, which is 0.75, all over 6 times 165.75 minus 29.5 all squared. This will simplify to 0.1903. So therefore, our t statistic is calculated to be beta hat all over the standard error of b hat. So our t statistic is therefore calculated to be t equal to b hat all over standard error of b hat, which is equal to 2.16 all over 0.1903, and this will give us 11.4. The critical value of t at p equals to 0.05 and 4 degrees of freedom. The degree of freedom is n minus 2. That is 6 minus 2, which would be 4. So the critical value of t at p equals to 0.05 and 4 degrees of freedom is obtained from the student t table as t 0.0254. Please note the test is a two-tailed test, so we are dividing the p here by 2 to have 0.025 with 4 degrees of freedom from the student t table. This will give us 2.78. So in conclusion, we have that the test is highly significant since the calculated t value, which is 11.4, is greater than the table value, which is 2.78. So therefore, we conclude that there is a linear relationship between the distance covered and weight loss. Finally, C, we were to estimate the weight loss for a client that covered a distance of 6 kilometers, putting x equal to 6 in our regression equation. That will give us y estimate equal to minus 2.8 plus 2.16 times 6, which is equal to 10.2 kg. So the weight loss for a client that covers a distance of 6 kilometers is 10.2 kilograms.